think I have to start over. Alright. Notice the 2001, 2002, 2003, 4, and 5. All of these are different values. And so the question is this a function? The answer would be yes. If any of those values were repeated, then the function would not be, then the association would not be a function, the mapping. Okay, so this is a function because none of those x values are repeated. Number 2. Find all real values of x such that f of x equals 0. Well, I have to set this equal to 0 and then solve. I'm going to actually make this a little, a little bit bigger. Alright. So I take 25x squared minus 4 equals 0. I can recognize this as a difference of squares, but I can also merely solve this. Okay, so x squared is equal to 4 over 25. Now I square root both sides, and I will get that x is equal to plus or minus 2 over 5. And that's my answer. Okay, so now we're going to shift over here to number 3. Okay, find the domain of the function. That tells me, since I have a square root, that has to be greater than or equal to 0. So I get 81 is greater than or equal to t squared. All I did was add t squared to both sides. Now I'm going to square root plus or minus 9 is greater than or equal to t. So now we have to think about this to figure out whether it's C or E, right? Because one is an and the other is an or. One says t is between the two numbers, and negative 9 and 9, and one says it is only outside. So when we look at this and we see we're subtracting t squared, we're going to have a problem if t is greater than 9, right? So that means it has to be less than 9. Even if it's negative 9, it's going to have a problem if the value is negative 10. So what I'm looking for is in between the two. So that means my answer is going to be C. Alright. Alright, let's move up. Now we're at 4. Okay, for 4, find the value of x for which these are equal. So I'm going to just set them equal to each other. So I have x squared plus 5x minus 57. And I have, this is equal to 4x minus 1. I get everything on one side so I can factor because I have the x squared in it. So I'm going to have x squared, subtract 4x, so it's going to be just plus x. Add 1 to minus 57, and I get, whoops, not a plus. This is going to be a minus 56. I factor this, and I'm going to get x. Factors of 56 that subtracted 1 are 7 and 8. This plus right here, this plus tells me that the larger number has to be plus. So I'm going to put a plus right there on the 8. And the 7 gets a minus. So this means, well, these are equal to 0. This means that x equals negative 8 and 7. So, negative 8 and 7. Alright, moving to the next. Alright. Alright, use the graph of the function to find the domain and range. Well, notice that for x equals minus 2, I only have one value because it's on the negative 2 but not on the negative 1. So this means that my domain goes from all the negative x values to all the positive x values. So my domain is all real. Alright, so what does that mean down here? Domain is all real. Well, it looks like I am going to have e, but let's double check the range. It says minus 2 and minus 1. Well, remember, it had that kind of function to it. So let's go. Sure enough, look. Minus 1 and minus 2 are the only two values the y will ever have. So this is definitely e. Alright, now we're going to look at number 6. Use the vertical line test to determine in which of the graphs is not a function. Remember now, vertical line test, if I can hit the graph in more than one place, it's not a function. And notice on this one, I can hit 2 places. So this one is not a function. The rest are all functions. All my vertical lines hit in only one spot. Alright, so what that means is that this is definitely, D is the one that is not a function. Sorry if I'm making you nauseous by making this rotate like this. I'm bad at it. Okay. Find the zeros of the function algebraically. Square root zeros. So what we're going to do is set these equal to 0. Isolate the square root. Square both sides. So now we have minus 7x equals 81. Divide both sides by negative 7. X equals negative 81 over 7. So negative 81 over 7 is A. Alright, now we're going to move on to number 8. Which graph represents the function? Okay, this is an integer function. So, what we have to do is look at this and pick a point and think about it. Okay, let's look at, well, I know that with this is going to be my function. It is always that diagonal. So the question is, notice here, this one they flip directions. Am I supposed to flip directions just because it says minus 1? And the answer is no. I do not flip directions. Oh, those aren't... Oh, they flip directions here, and they shouldn't. It should always stay the same side. If we check a number, let's check a 3. If I put in 3, minus 1 is 2, so the integer would be 2. So if I put in 3, I should be equal... That can't be that one, can it? If I put in 3, the answer should be 2. Oh, there it is. So it is B. But that doesn't seem right. So let me double check. We have one hiding here. Ah, here. There we are. Okay. See? 3. It goes to 2. Yes, that's correct. And this one does not flip directions as it goes down. So the answer's got to be C. Alright. And now we move on. Here's number 9. Which function does the graph represent? Well, I can see right off it's an integer function. Notice that the point, I normally have a filled-in point here and then an open circle there. Notice my filled-in point has been shifted backwards 3, so I will probably have an x minus a negative shift of 3. And yes, I've given that option, so there we go. The other option is you might have had a vertical shift. 10. Evaluate the indicated function for f of x and g of x. Well, this is just multiplying two functions. So if I plug the minus 1 in, I get 1 minus 9 for f of x. 1 minus 9 is minus 8. For g of x, I get negative 1 minus 5 is a negative 6. I multiply those together, I'm going to get a positive 48. And that was really badly written. Look at that. A positive 48. So the answer is C. Alright, now find f divided by x. Alright, we have 9. Minus 9x squared plus x over 2 minus x. Minus 9x squared plus x over 2 minus x. That's correct. Those three are correct. So my domain, this cannot equal 0. So 2 cannot equal x. Okay, the only one that has the right function and the 2 is D. Alright, we have one more on this page. Sorry, I'm shaking all over the place. There we go. Use the graphs of f and g to evaluate the function f circle g of 1. Well, this is the easiest way to do this is I can take... Oops, I apologize. There we go. Alright, there we are. So, this is the same thing as saying f of g of 1. Well, what's g of 1? I come to 1. Look, g of 1 is 0. So that's like saying f of 0. 0 for f is actually negative 2. So my answer is negative 2. Alright, last page. Okay, we're going to make it a little bigger. Alright. Determine whether the function has an inverse function. If it does, find said inverse function. Okay, one of the ways to do this is to graph it. Alright, but we're going to find it algebraically. Plug in a y. Switch x equals y squared plus 2. X minus 2 equals y squared. Square root of x minus 2 equals y. Alright, so the inverse function would be the square root of x minus 2. Yes. Okay. 14. Describe the sequence of transformations from the related common functions. Alright, so we did this a whole bunch in class. Down 6 units down. Oh, no, it's not down. I'm sorry. It's minus 6, so it's to the right. 6 units right. I apologize. Alright, so transformation from the first to the second. 6 units right. Looks like that's my only 6 units. Left, up, left, down. 6 units right. Yeah. Okay. And a vertical stretch of 5, which is true also. Okay. vertical stretch of 5. Alright, let's go over here to 15. Use the graph of f of x equals x squared to write an equation for the function whose graph is shown. Alright, so what we know is this graph has been shifted 1 unit in the x, so that's going to give me an x plus 1, because we subtract the negative shift. And we know it's going to be shifted down 2 in the y. So x plus 1 squared minus 2. Alright, we have a winner. X plus 1 minus 2. There we go. Alright, we're going to move on. Now, this is our free response. I told you about this one that it was coming. So, to use composition of functions, what we're going to do is we have to take f of g of x and g of f of x. So f of g of x is f of x squared minus 8, which is the square root of x plus 8, no. Square root of x squared minus 8 plus 8. Well, these two add to 0. So now I have square root of x squared, which is x. Yay! Alright, for the second one, now we have g of square root x plus 8. Well, that's equal to square root of x plus 8 squared minus 8. Well, the squaring the square root turns this into an x plus 8 minus 8. Those add to 0. I have just x. And sure enough, with both of these equaling x, we have proven they are inverses. And I told you this is going to be on the test. Okay, we're all done.